Stars and planets, celestial wanderers of the cosmos, captivate our imagination. These luminous bodies and their planetary companions have been the subject of human curiosity and study for centuries. From ancient astronomers to modern-day scientists, the quest to understand these celestial objects has driven countless hours of observation and research. But what sets them apart? How do we distinguish between these two types of celestial bodies that share the vast expanse of space? Stars are immense balls of burning gas. They are primarily composed of hydrogen and helium, the two lightest elements in the universe. They generate their own light and heat through nuclear fusion. This fusion process is what makes stars shine so brightly in the night sky. This process occurs in their cores, where hydrogen atoms fuse to form helium, releasing an incredible amount of energy. This energy radiates outward, giving stars their characteristic glow and warmth. Planets, on the other hand, are much smaller and cooler. They come in a variety of types, including rocky planets like Earth and gas giants like Jupiter. They lack the internal furnaces of stars and do not produce their own light. Instead, they rely on their host star for illumination. Instead, they reflect the light of their host star. This reflected light is what makes planets visible to us from Earth. Planets wander through space, held in orbit by their star's gravity. This gravitational pull keeps them in a consistent path around their star. Our own solar system provides a familiar example. It is a complex and dynamic system where each planet follows a unique orbit around the Sun. The Sun, a brilliant star, reigns supreme at its center. Its immense gravitational force governs the motion of all the planets within the system. Orbiting the Sun are 8 planets, including our home, Earth. Each planet has its own unique characteristics and conditions, contributing to the diversity and wonder of our solar system. Stars, like cosmic fireflies, experience a life cycle filled with dramatic transformations. These celestial bodies are born, live out their lives, and eventually die, leaving behind remnants that continue to influence the cosmos. They are born from collapsing clouds of gas and dust known as nebulae. These nebulae are often referred to as stellar nurseries, where the conditions are just right for star formation. Gravity draws these materials together, increasing density and temperature. As the gas and dust clump together, they form a protostar, a young star still in the process of gathering mass. Eventually, the core becomes so hot and dense that nuclear fusion ignites, marking the birth of a star. This process releases an immense amount of energy, causing the star to shine brightly. The lifespan and eventual fate of a star depend on its mass. Massive stars have shorter lifespans, burning through their nuclear fuel quickly, while smaller stars can last for billions of years. Massive stars live fast and die young, exhausting their nuclear fuel rapidly. When they run out of fuel, they undergo a dramatic end. Smaller stars, like our Sun, burn steadily for billions of years. They go through a more gradual process of aging, expanding into red giants as they near the end of their life cycle. When a star exhausts its nuclear fuel, it can no longer maintain its outward pressure against gravity. This leads to a series of events that determine the star's final fate. The star's core collapses, leading to dramatic events. For massive stars, this collapse results in a supernova explosion, one of the most powerful events in the universe. Massive stars explode as supernovae, scattering their outer layers into space and leaving behind a dense core, which can become a neutron star or even a black hole, while smaller stars like our Sun expand into red giants before shedding their outer layers. This process creates beautiful planetary nebulae, which enrich the interstellar medium with heavy elements, leaving behind a dense core known as a white dwarf. These remnants can shine for billions of years, slowly cooling and fading away, a silent testament to the star's once vibrant life. The question of whether a star can transform into a planet is intriguing. While stars can undergo dramatic transformations throughout their life cycles, the process of becoming a planet-like body is not a direct one. Stars and planets form through distinct processes, and the conditions required for their formation differ significantly. Stars are born from the gravitational collapse of massive clouds of gas and dust. Planets, on the other hand, form from the leftover material swirling around a young star. This material, known as a protoplanetary disk, gradually clumps together under the influence of gravity, forming planetesimals. These planetesimals continue to collide and accrete, eventually growing into planets. While stars cannot directly transform into planets, certain stellar remnants bear some resemblance to planets. White dwarfs, the dense cores left behind after a sun-like star exhausts its nuclear fuel, are incredibly compact. They can be similar in size to Earth, but with a mass comparable to that of our Sun. Brown dwarfs, often referred to as failed stars, occupy a curious middle ground between stars and planets. They are more massive than planets, but lack the mass to sustain hydrogen fusion in their cores. As a result, brown dwarfs emit faint light and heat, gradually cooling over billions of years. Section 5. The Curious Case of Diamond Planets. In the vast expanse of space, astronomers have discovered intriguing objects that hint at the possibility of unusual transformations. These celestial bodies challenge our understanding of planetary formation and composition. One such discovery is the exoplanet 55 Cancri E, a super-Earth twice the size of our planet. This exoplanet has captivated scientists and space enthusiasts alike due to its unique characteristics and potential insights into planetary science. This planet orbits a sun-like star located about 40 light-years from Earth. The star, known as 55 Cancri, is part of a binary star system, making the dynamics of this exoplanet even more intriguing. What makes 55 Cancri E so fascinating is its composition. Unlike Earth, which is primarily composed of silicate rocks and metals, 55 Cancri E is believed to have a very different makeup. Scientists believe that this planet is primarily made of pure, crystallized carbon. This hypothesis is based on the planet's density and the spectral data collected from telescopic observations. Due to the intense pressure and heat deep within the planet, this carbon has likely formed a gigantic diamond. Imagine a world where the landscape glitters with the brilliance of diamonds, a stark contrast to the rocky terrains we are familiar with. While not a direct transformation from a star, this discovery highlights the extraordinary conditions and compositions that can exist in the universe. It opens up new avenues for research and fuels our curiosity about what other wonders might be out there, waiting to be discovered. The study of such exotic planets not only enhances our understanding of the cosmos, but also inspires future missions and technological advancements in space exploration. Who knows, perhaps one day, humanity will set foot on a diamond planet, unraveling more secrets of the universe. Section 6. Planetary formation from dust to celestial bodies. The formation of planets is a captivating process that unfolds over millions of years. It begins with a protoplanetary disk, a swirling disk of gas and dust surrounding a young star. Gravity acts as the architect, pulling particles of dust and gas together. As these particles collide, they stick together, forming larger and larger clumps. These clumps, known as planetesimals, continue to grow through accretion, gradually clearing their orbital paths and accumulating more material. Over time, planetesimals evolve into protoplanets, the precursors to fully formed planets. Section 7. The unlikelihood of stellar to planetary evolution. While the idea of a star transforming into a planet is captivating, it is not supported by our current understanding of stellar and planetary evolution. Stars and planets form through distinct processes, and their evolutionary paths diverge significantly. Stars are born from the gravitational collapse of massive clouds of gas and dust, while planets form from the leftover material swirling around young stars. The conditions required for star formation, such as high temperatures and pressures, are not conducive to planet formation. Section 8. Exploring the cosmos. Unraveling the mysteries of space. The universe is a vast and enigmatic realm, filled with celestial wonders that continue to amaze and inspire us. From the fiery birth of stars to the intricate dance of planets, the cosmos offers endless opportunities for exploration and discovery. As we delve deeper into the mysteries of space, we gain a greater appreciation for the complexity and diversity of the universe. Each new discovery expands our understanding of the cosmos and our place within it. Section 9. Fun fact: a universe of wonders. Did you know that there are more stars in the universe than grains of sand on all the beaches on Earth? This mind-boggling fact highlights the sheer immensity and grandeur of the cosmos.